Welcome back. Last time we discussed how to find the derivative of a function using the definition. The definition was the limit of the difference quotient, f of x plus h minus f of x divided by h as h approaches 0. Today what we're going to do is we're going to find shortcuts to find the derivative of certain functions, as well as something like polynomials or trigonometric functions, simplest cases. And later on we will build on these. So here let's start with the constant function, derivative of a constant function. So if you think about the derivative, always go back to the original idea. What is the derivative? The derivative tells you the slope of the tangent line. So if you have a constant function, what do you know about that constant function is, so let's say this is the constant function, this dashed line. Okay, what do you know about this is that the slope is always 0. Doesn't really matter what location you look at it. If you pick 2 points on this graph, the change in x, the change in y, divided by change in x would be change in y. There is no going up, always 0. Denominator could be 1, 2, 12, whatever that is. Always 0. That tells you the slope is always 0. There is no increasing in y direction. There is no rise in along the y-axis. Okay, so what does it mean is if you look at any point and draw the tangent line turns out to be the same as the function. So what is the slope of the tangent line? It's simply 0. So what does it mean is the derivative is 0. You can calculate this using the definition as well. Limit f of x plus h minus f of x divided by h as h approaches to 0. Given the function f is a constant c. So what do you get is limit, what is f of x plus h? In the function f, every time I see x plus x, I replace x plus h. But in the function f is a constant. It doesn't depend on x at all. So the function f of x plus h is still going to be that constant. Minus f of x is still c divided by h as h approaches to 0. What do you get in the numerator is 0. This is 0. So 0 divided by h, simply 0. So what does it tell me? It tells me the derivative, a function is 0. So we can say the derivative of any constant as a function is 0. So if you have a function that is constant, the derivative is always 0. So the derivative of 2, for example, it would be 0. The derivative of 3.5 would be 0. Derivative of square root of 5 would be 0, as long as square root of 5 is constant. There is no x or anything in front of it. Okay, the power rule, there is multiple ways to start with the power rule. Is one way is to look at go through the x to the power 1, x to the power 2, x to the power 3, and so on, and calculate the derivatives for those and see the trend. But what I'm going to do is, sorry about that. What I'm going to do is I try to, can I undo this? There's no undo option, seems like. Okay. Something is wrong with this. Okay, let's. For some reason, oh, there we go. X to the n equals n x to the n minus 1. Okay, here. Okay, so what I'm trying to do is just give you a hint of where the power rule comes from and what the power rule is. So I do not give you the whole proof, but the proof is available in the textbook. So let's go through the short idea of the proof. Okay. Every time you want to calculate the derivative, you always go back to the definition. F of x for something new that you don't know. F of x is x to the power n. N could be 5, 6, 2, 3, doesn't really matter. Later on, I can say that in general, n could be any number. It could be 0.5, be 0.3 and so on. But let's assume first we only look at the integers. Okay, what would be f of x plus h? This is the only thing that is important. If you're given an x to the power n, what is f of x plus h? It would be x plus h to the power n. Okay, so now what does this mean? It means you have to write x plus h multiple times and distribute these guys over and over. How many times you write this? You write it n times. Okay, so what you get is x to some power n, because you multiply x by x by x and so on. You multiply x by and so on, then at the end you multiply an h to them. So you'll get x to the power n minus 1 and you multiply an h. So what I try to distribute, let me write it for 3 of them so you can see. Let's say this h n was 3. That means you multiply x times x times x. Sorry. X times this, x times that x. So you'll get x to the third power. And you multiply this x by that x, then you decide, okay, now I want to multiply it by h. So you get x squared times h. So x to the power 3 minus 1, which is 2, times h. Then you can consider doing this over and over. What you do next is you multiply this x by h, then you multiply that h by x again. So what you get is another x squared h. So at the end you'll get plus another x to the n minus 1 times h. You get how many of these? You will get 3 of them in this case, because you have combination of 3. But in general, there's a way to multiply these, and what you get is n x to the n minus 1 h. And the next one will contain whatever this coefficient is. We'll have h squared times something, times x to the power n minus 2 times some coefficient. In this case, it would be n times n minus 1 divided by 2, whatever that is. Okay, I don't really care about the coefficient. What I want to say is the next one will have h cubed times x to the n minus 3 and everything. And if you continue, you'll have h has higher degree. So what do you see is limit f of x plus h would be all these stuff minus f of x. So it would be minus x to the power n. And what does it give you? That is, these two terms will cancel out. And what is left is nx to the n minus 1 times h plus something times h squared times x to the n minus 2 plus something times h cubed times x to the n minus 3 and so on. All these other terms. All divided by h as h approaches to 0. Again, you don't need to know this proof, but if you're a math major, it's good to know it. So I'm just going to give you a brief idea of how this rule comes from. Okay. Cancel out the h. This h and that h will cancel out. One of the h here will cancel out with this h. What I'm basically doing is I'm trying to factor. One of the h's here will cancel out, so you'll get your h squared. So what you get is limit h approaches to 0. N x to the n minus 1. There's no h because I canceled that. Plus the next one will be h times x to the n minus 2 times some term here and n minus 1, whatever this coefficient is. There will be a coefficient here at the front multiplied by this guy. Plus, not O, there's a star, some constant multiply. Plus another 1 times h squared xn minus 2 minus 3 and so on. What I'm trying to say is, at this point, if you look at the limit, h goes to 0. That means this term is 0. Replace h with 0. This term becomes 0. The next one becomes 0. So all these will become 0. So everything multiplied by 0 will cancel out. What is only left is this term. And that is basically our derivative. That means if you're given a function like x to the power 3, x to the power 4, x to the power 5, what you need to do is decrease the exponent and drag down the exponent as a coefficient. So simply, if you're asked to calculate the derivative of x to the power 3, what you need to do is subtract 1 from the exponent, 3 minus 1, and put that 3 up front. This would be 3x to the power 2. This is the derivative function. That is the shortcut for all those stuff. Instead of going through the procedure, this would be the shortcut. Okay, the constant multiple rule. What is the constant multiple rule? Constant multiple rule is if you have a constant multiplied by a function, and if you want to take the derivative, you can ignore that constant as a multiplication and multiply it later. So this is all properties of the limit. Limit f of x plus h minus f of x, if they all had a c in front, divide by h as h approaches to 0. What you could do is you can write the c outside, and you have f of x plus h minus f of x divided by h as h approaches to 0. This c can stay. What is this? This is basically the derivative. And what you start with is the c derivative, cf derivative. Derivative of a constant multiplied by a function is basically they keep the constant and multiply the derivative later. Okay, so here as we going on, I'm gonna write changes in notations as well. So if you have a constant, derivative of any constant is 0. Power rule, it says x to the n. So if you have x to the n, you want to take the derivative from it. Derivative would be n x to the n minus 1. We will do examples of these, but I want to show you the notation as well. If you have a c times a function, and you want to take a derivative, as long as this c is a constant, write f of x. What you get is c times the derivative of the function. Ignore the c at all. C is just a constant multiply. Sum and difference. This is another property that if you have two functions added together or subtracted from each other, you can use this property of limit. You can break it up and write this two separate functions. So that means if you have f plus or minus g function, and you want to take the derivative, you can simply say, okay, I will write the derivative of f, I'll find the derivative of g, I will add them, or I will subtract them, depending on if they're added or subtracted. Okay, again, all these proofs are available in the book. It's nothing different. The product rule is the one of the important rules, product and quotient rule. Product rule is kind of tricky. You have to be careful. This notation is kind of confusing. There are too many d over dx. So here is the easier way to see it. If you have two functions multiplied by each other, f times g, and you want to find the derivative, this prime means the derivative of this whole thing. What you need to do is find the derivative of the first function multiplied by the second function. The second function is not the derivative, it's the original function. Added with the first function plus the derivative of the second one. This is easier to remember than going through all these dx or dy. But this is what it means. This is the same as that. That one is the same as this guy. Okay. And instead of writing dx's, I prefer this prime because it's less confusing. Okay, how about the quotient? Quotient, again, this is another way to write it, but the best way would be if you have two functions divided by each other. What would be the derivative? Derivative would be derivative of the first times the second function. If you remember, compared to with the multiplication. In the multiplication, there was addition, but here in the fraction would be subtract. Derivative of g times f, and the only difference is you gotta divide by the denominator squared. The numerator, derivative multiplied by the denominator minus the numerator times the derivative of the denominator, all divided by the denominator squared. Again, we do examples of this, but I just want to show you the notation. These are product quotient rule. All can be proven by using the definitions of the limit. Okay, the definition of the derivative. No, sorry, not the limit. Okay, so here is the example. We want to find f prime for all these cases. Okay, f of x is given 5. What is f prime? Derivative of any constant? 0, first rule. Derivative of 5, simply 0. F is given x cubed. We already did this example, but let's try it one more time. Let me change it actually to a different number. Let's say if it was 30. What would be derivative? Drag down the 30, subtract 1 from the exponent, 30 minus 1. So you will get 30 x to the power 20. The same rule applies to negative exponent as well. So here, f prime x, what is it? Let's assume this 3 wasn't there. What would you do to find the derivative? You would say, okay, let's drag down the negative 2. Multiply x to the power negative 2 minus 1. Subtract 1. If there is a 3 up front, multiply by this. Just multiply that 3 as well. This is the constant multiplied by a function derivative. Okay, so what we get is 3 times negative 2 is negative 6. X to the negative 2 minus 1, x to the negative 3. Okay, I'm following power rule as well as multiplying a constant by a function. How about this case? Square root of x. You might ask, okay, we didn't learn anything about the derivative of square root. Not really, but we learned it about x to some power. X to the power 1/2. What do you take? What the derivative is? Again, you drag down the exponent, subtract 1 from the exponent, 1/2 minus 1. It's the same rule, it's the same power rule. You always drag down this exponent and subtract 1 from the exponent. So 1/2 x to the power 1/2 minus 1 is simply negative 1/2. You can rewrite this as 1/2 times, you can move this to the denominator, make it positive, x divided by 1 divided by x to the power 1/2. And this is 1 times 1 is 1. 2 times x to the power 1/2 is square root of x. So you get 1 divided by 2 root x. Okay, now how about this? What if you have functions added or subtracted from each other? It's not really any different. Consider each one separately. Derivative of x cubed, we already calculated this. It'd be drag down the exponent, subtract 1 from the exponent. You can do it in step by step. Minus derivative of 2x. Here is what you should be careful. Let me change this to 2x squared. I'll do 2x later. So here I'll do 2x next line. Let's try 2x squared first. Derivative of 2x squared would be keep the 2. This is the coefficient. This is this coefficient 2. I kept it. Now I drag down the other 2 times 2x to the power 2 minus 1. Subtract 1 from the exponent. And plus derivative of pi. You may ask, what is the derivative of pi? We don't really know, but you know, since pi is a constant 3.14 whatever, derivative is simply 0. Not that just since it's pi we don't know what to do about it. It's a constant, derivative is simply 0. Okay, now simplify it. X to the power 2 minus 1 is x to the power 1 minus, sorry, this is 3 minus 1, not 2 minus 3 minus x to the power 2. Negative 2 times 2 is negative 4. X to the power 2 minus 1, simply 1. So this would be the derivative function. Okay, before I go to the next example, let's mention that f of x equals x first. What would be the derivative of f of x equal to x? The simplest case. What is the exponent? Exponent is 1. So I drag that 1 down. Subtract 1 from the exponent. 1 minus 1. What do you get is 1 times x to the power 0. What is the x to the power 0? X to the power 0, any number to the power 0 is 1 except 0. So here in this case, x to the power 0 is simply 1. So 1 times 1 is 1. So the derivative of x is 1. If it was 2x, what you do is you keep the 2, you multiply it later. Derivative would be 2. Okay. So be careful. If it's x, you got to write that 1, drag it down. X to the power 0 is always 1. So here is the important thing. X to the power 0, 1. Don't mess this up. Okay, let's go to the next example. 3 to the power 5. What is the derivative of that? Is it 5 times 3 to the power 4? Sorry, 5 minus 1. Not really. Do not do this. Ask yourself, what is 3 to the power 5? Does it involve x at all? Not really. 3 to the power 5 is a constant. It's 3 times 3 times 3 times 5 times. So what you get is derivative is not this power rule. Derivative is simply 0, since it's a constant. So minus pi squared x. What is the derivative of pi squared x? Again, pi squared is a constant. Keep it there. Since it's multiplication, you should keep it. Derivative of x, we just discussed it, is 1 times x to the power 1 minus 1, which is 0. So it would get you negative pi squared times 1 times 1, which is negative pi squared. Sorry about that. Okay. How about the next example? What is the derivative of this function? F prime x. Here's what you should be careful. This is a power 2, but it's not simply x to some power. So there are multiple ways to deal with this. One way is to write it as 2x plus 5 times 2x plus 5 and use product rule, because you have one function times another function. The other way is you can multiply, distribute all these, and then at the end take the derivative. They both should give you the same result. I'm going to show you both ways. First, let's go through the product rule, because product rule is kind of necessity. Okay, so product rule means I wrote this function as multiplication of two functions. Let me rewrite this clearly. So I write it as 2x plus 5 times 2x plus 5. And I want to take the derivative of this. I'm going to call this first part, let's say f, this is g. Maybe f and g are not good since we already have n g. Let me use star and circle, star and square or something. And write the product rule. What is the product rule? If you have star times square and you want to take the derivative, it is derivative of star times square plus star times derivative of square. This is what you need to do. So if I want to take the derivative of f, I simply follow this rule, since I have product of two terms and they're both functions. So derivative of 2x plus 5, I'll figure out that. I'll multiply it by the other function, which is the square function. Turns out to be 2x plus 5 again. And I'll add the star function, 2x plus 5, multiply by the derivative of the square function, 2x plus 5. Okay. Okay, so what is the derivative of the first parentheses? We got to figure out what is this derivative. 2x plus 5 derivative. Derivative of 2x, we calculated the derivative of 2x here. Became 2. So this first parentheses, simply 2. Times, I don't need to take the derivative of the second term. It doesn't have the prime notation. So I keep it. Here the same. I don't need to take the derivative because it doesn't have the prime. How about the derivative of 2x plus 5? Simply 2 again. Why only 2? What happened to the 5? Derivative of 5 is 0. Don't forget this. Derivative of this was 0. Derivative of 2x is simply 2. Same here. Derivative of 2x is 2. Derivative of 5 is 0. Okay. So now you can distribute and say, okay, 2 times that, 2x plus 5 would give me 4x plus 10. And here you get another 4x plus 10. What you get as the derivative is 8x plus 20. This would be the derivative function. So it is important that you go through the procedure. There is shortcuts for this later as well, but we don't know that you need to know composition of functions derivative. If you distribute first, if you calculate this 2x plus 5 squared, what you get is 4x squared plus 20x plus 25. If you raise it to the power 2, this is equal to that. So what is the derivative of 4x squared? It becomes 8x. What is the derivative of 20x? It's 20. So you should get the same result. It doesn't really matter which way you go, you should get the same. I recommend try either way, figure out which way is the simplest, but product rule is always a necessity to know. Okay, how about this example? Maybe I should create some space here. Okay. The function f is given as 2 over x minus 1 over square root of x. There are multiple ways to take the derivative. I'm going to write this example without using the quotient rule. Next time I'll do the quotient rule just to show you there is another way to do the derivative here. So one way is to write this as 2 divided by x is the same as 2 times x to the power negative 1. You can write it this way. X to the power 1 can go to the numerator and become x to the power negative 1. 1 divided by square root of x is the same as 1 divided by x to the power 1/2. I can move this up and write it as negative exponent. So I can write f actually as 2x to the negative 1 minus x to the minus 1/2. Move this to the numerator again, it becomes negative. So now to take the derivative, I can use the power rule. Keep the coefficient 2. Derivative of x to the negative 1 multiply by negative 1 times x to the power negative 1 minus 1. Subtract 1 from the exponent. Minus, drag down the exponent, negative 1/2 times, subtract 1 from the exponent, negative 1 minus 1. So what we get as the derivative is 2 times negative 1 is negative 2. X to the power minus 1 minus 1, x to the power minus 2. Minus times minus becomes positive 1/2. X to the power negative 1/2 minus 1, that is x simply negative 3 over 2. So if you rewrite the function, again back it to the fraction, negative 2 is there, x to the power negative 2 can move to the denominator and become x squared. 1/2 is still there, x to the power negative 3/2 can move to the denominator and become x to the power positive 3/2. Which is the same as saying negative 2 divided by x squared plus 1 over 1 times 1 is 1, 2. X to the 3/2 is x cubed square root. So this is basically the derivative of the function f. It is kind of too much at this point, but if you try more examples, it becomes easier and easier. Okay, I want to show you a different way that this example that I'm going to do in next. But for this one here, this function f of x equals to x squared plus 4x divided by x minus 3. We don't have the luxury to rewrite this negative exponent. What we can do is we can use the quotient rule. And what was the quotient rule? Quotient rule was, use a different color. If you have f divided by g, you want to take the derivative, it would be f prime times g minus f times g prime divided by g squared. Okay, so the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator divided by the denominator squared. This is the quotient rule. So I'm going to write the quotient rule for this function f. What do I get as the derivative? Numerator derivative would be x squared plus 4x derivative times denominator x minus 3 minus, again notice that this denominator in the formula does not have any derivative. There is no prime here, neither there is no prime here. So minus x squared plus 4x derivative multiplied by the derivative of denominator x minus 3 derivative, all divided by x minus 3 squared. Denominator does not have any derivative. You could have done this formula for the last example as well. I recommend maybe try that in the last example to see what do you get. It should give you the same result. Okay, let's calculate these derivatives and simplify. Derivative of x squared plus 4x. What is that derivative? Derivative of x squared, drag down the exponent, subtract 1, 2x to the power 2 minus 1, plus derivative of 4x, 4 times 1, this is x to the power 1. Drag down the 1, subtract 1 from the exponent, x to the power 0. Derivative of x is simply 1, so you can simply say this is 4 times 1. But I want to write these steps once or twice till you guys get comfortable. After that, you can skip ahead through these steps. Derivative of x minus 3, derivative of x is again 1 times x to the power 0 minus 3. Derivative of 3 is 0. Derivative of constant is 0. All divided by denominator squared, x minus 3 squared. Finally, I can calculate and say this is 2x plus 4, x to the power 0 is 1, times x minus 3 minus x squared plus 4x times derivative of 1 times x to the power 0 is simply 1. I'll divide by x minus 3 squared. I'm okay if you leave it like that, but general rule of thumb is that you can distribute the numerator and simplify. Here at this point there is no more derivative left. There is no prime notation. Since I only care about the derivative calculation at this point, I will leave it at this point. I'm comfortable if you write it like that, but the exam normally they want you to distribute and simplify the numerator. Okay, how about one more thing is that in all these examples that I did, there was variable x, but if I change the variable to t, it's not going to make any difference. Here, if they ask you what is f prime of t, what you need to do is you should consider that you have two parentheses multiplied by each other. Each one is a function, like the star and square. So I will say it's the star derivative. It's the product rule. I mean, applying the product rule. Derivative of the first one times the second function, 5 square root of t, minus cube root of t squared, plus, again, write this, times the square, plus star times square derivative. This by itself does not make sense unless on the other side they say there is star times square and you want to figure out the derivative of that. That's what we're trying to do. You're given the star times square and you want to find out the derivative. The product of two functions, you want to find out the derivative. Okay, so it would be the first function derivative multiplied by the second plus the first function, t to the negative 2 plus 3t times the derivative of the second, 5 square root of t minus cube root of t squared derivative. Okay, some of these derivatives are easy, some are kind of complicated. For example, the first part is easy. Derivative of t to the negative 2, this is power rule. Drag down the negative 2, subtract 1 from the exponent. Negative 2 minus 1. Derivative of 3t, same thing. Keep the 3, drag down the exponent. Exponent is 1, so times 1. Derivative of, subtract 1 from the exponent. 1 minus 1. Multiply by the way, there is no prime anymore because I already applied the derivative. Multiply by the second function, 5 square root of t minus cube root of t squared, plus t to the negative 2 plus 3t. These guys don't have any derivative. Now here is the part that you should be careful. What is the derivative of 5 square root of t? Again, if you cannot take a derivative of square root of t, you can write it as t to the power 1/2 and think about that and say, okay, I can take the derivative here using the power rule. It's 5 times, drag down the exponent, 1/2, t to the power 1/2 minus 1. Subtract 1 from the exponent. Minus, same here, same problem. You cannot take the derivative of that unless you write it as t to the power 2/3. Cube root of t squared is t to the power 2 divided by 3. So now I can apply the power rule. Drag down the exponent, 2/3 times, subtract 1 from the exponent, 2/3 minus. Now you already have the derivative. It's just a simplification. It means I'm going to deal with those exponents. You get negative 2t to the negative 3 plus, this is t to the 0, which is 1, times 3 times 1, 3, times 5 square root of t minus cube root of t squared plus t to the negative 2 plus 3t times 5 times 1/2 is 5/2. T to the 1/2 minus 1 is t to the negative 1/2. 1/2 minus 1 is negative. Minus 2/3, t to the 2/3 minus 1, negative 1. Okay, everything else should stay the same. You can cancel out, maybe you can rewrite these maybe in terms of square roots or something. 5/2, t to the negative 1/2, you can write this as 1 divided by t to the positive 1/2, which is the same as square root of t. And here you can write this as negative 2/3 times 1 divided by t to the 1/3, t to the 1/3. But what is t to the 1/3? It is cube root of t to the power 1. So you can write this cube root of t to the power 1. Normally this is not necessary if there is other negative exponents. If there is other negative exponents, I would not do this. But just I wanted to show you that you can always apply these to any type of root. Doesn't really matter if it's third root, cube root, fourth root. As long as you have simply, you can write it as a power function. Okay, here one more example to see the difference between some cases. Given this function f, 2/3 plus 2 over 3x plus 2x over 3, we want to find out what is f prime. Okay, so what is f prime? Derivative of 2/3. There is no x involved. This is a constant. This is a number. Simply 0. Derivative of 2 over 3x. You can use the quotient rule. You have a fraction. So what would be derivative? It would be derivative of the numerator multiplied by the denominator minus, use parentheses just to make sure, minus numerator times the denominator derivative. All divided by denominator square, 3x squared, use parentheses, plus 2x over 3. You can use quotient rule. You can say, okay, 2x derivative times the denominator minus 2x times the denominator derivative divided by the denominator square. There's a simpler way for each one. This one you can write as 2 over 3 x to the negative 1. This is the same as 2 over 3 x to the power 1. And each one, 2 over 3rd is a coefficient. You can ignore it till later. Take the derivative of x to the negative 1 and x to the power 1. But I wanted to show you that you can apply the quotient to either one as well. It's still going to give you the same result. Okay, so if you apply the quotient, what do you get? This term, first term was 0 plus, okay. What is the derivative of 2? Derivative of 2, this is 0. 0 times 3x doesn't really matter, so this is gone. Derivative of 3x will be 3 times x to the power 1. So drag down the 1, subtract 1, so this is simply 3. So what you get is negative 2 times 3, you'll get negative 6. Divide by 3x squared. Do not write 3x squared like this, because this means only x squared, not the 3. 3x squared in parentheses means basically 3 squared as well, so 9. Let me make this. Plus, how about the other fraction? Derivative of 2x, simply 2. Derivative of 3, 0. 0 times 2x, this is gone. Divided by 3 squared. So what do I have is 2 times 3, 6, divided by 9. And what do you get? 0 plus negative 6, I can simplify it. Negative 2 over 3x squared plus 6 divided by 9, 2/3. I want you all to go back and say, okay, rewrite this in terms of 2 divided by 3x to the negative 1 and 2 divided by 3x. And figure out the derivative using power rule to see if you get the same thing as well. You should get the same result. One of them is very easy to see. 2/3 x. This is the coefficient. The derivative of x is simply 1. 1 times 2/3, you get 2/3. So this is just to show you that one of the rules, like power rule, could be applied even if the fraction form is there. you can rewrite in a way that you can use the power rule. Sometimes it's simpler to use power rule. Sometimes it's simpler to use quotient. Okay, this would be the topic for this section as well. 2.3. Next time we will discuss the derivative of the trigonometric functions. We've talked about polynomials. Now we know the derivative of polynomials. We know the derivative of certain rational functions. We know the derivative of square roots, at least the simple cases. Now, next we will discuss the derivative of sine, cosine, and such on, so on. Okay. I'm going to stop at this point.